In this case, I chose the two white dots for a molecule of an element because a molecule is two or more different or same atoms of an element. In this case, I chose two of the same atoms of an element because it says a molecule of an element, meaning it can only have one element. I chose the yellow dots this time because it is the only one on this table that is not a molecule. A molecule is two or more particles from the same or different element, and since this is only one particle, it is not a molecule. I chose two red dots combined together for a molecule but not a compound, because while a molecule is two or more of the same, different, or the same elements for a particle, but a compound is two or more particles from different elements, and since the red dots are the same element, we can choose that. In this case, I chose the yellow dots because a monatomic element is a particle with just one atom, basically, as a part of the element, and it's a pure substance because it only has the yellow dots. I chose two red dots and two white dots for this one because it is a mixture, because it has two different types of particles or molecules, and they are both diatomic, meaning they have two atoms in the molecule. For this, I chose the green and white molecule and the two red molecules because a diatomic compound is the green and white, and a diatomic element is the red. In this case, I chose these two triatomic compounds because a triatomic compound is a molecule that has three different atoms with two or more different elements in it. This is also a mixture because it has two different types of triatomic compounds. I chose these particles for a mixture of four different compounds because all four of these, including the four white and one black, two red, one green, one white, and two white and one red compounds, because all four are compounds and all four are different, and that makes it a mixture. This is H2O and H2 because the H2 right here is these two white particles, and H2 is also an H2O with these two white particles, and the oxygen is the red one. This is CO2 and O2 because in CO2, which is these particles right here, we have the red, two red, which will represent the two oxygen, and this black particle here, which will represent the carbon. In the O2, we have two oxygen, which are the two red particles, which makes it CO2 and O2. I chose these particles for HCl and AU because this includes hydrogen and HCl, and then chlorine, which would be the green particle. And AU, that's just one element, which would be the yellow particle. I chose these particles for CH4 and CO2 because for CH4, there is one carbon in the middle and then four hydrogen on the outside. For CO2, we have the two red oxygens on the outside and then the carbon in the middle. I chose this for a pure substance and diatomic compound because it is a pure substance because it only contains one type of molecule, and it's a diatomic compound because it has two particles that are both different in one molecule. This is a mixture of a triatomic compound containing H and H2 because this triatomic compound right here has one H, which is the red particle, and the other triatomic compound, this one right here, has two H's, one on each side, the red ones. This is a mixture of all the elements because it contains all the molecules and atoms that only have one element in them: the two whites, the two reds, and the yellow particles. This is water mixed with oxygen because these two red particles here is O2, which is oxygen, and the other compound, which is one red and two white, is H2O. This is a mixture of a compound and an element with only two different atoms because this is a compound right here and this is an element right here, and the two atoms that are used in this are the white atoms and the red atoms.